Hello everyone, welcome back to my YouTube channel. I'm Chandana, pursuing third semester in the Department of Electronics and Communication Engineering at Shivrateshwara College of Engineering, Bangalore. Subject Network Analysis, and today I'm going to discuss about the topic Superposition Theorem, and I'm going to solve a problem on this theorem. So let us see the contents. Superposition theorem and its statement, procedure for solving network by superposition theorem and problem related to this theorem. So statement of superposition theorem, it states that in any linear bilateral multi-source network, the response in any branch is equal to algebraic sum of the responses obtained by considering each source acting separately by making all other source set equal to 0. So this is the derivation of superposition theorem. So this theorem is applied to multi-source network. So consider the network as shown here. So first of all, we have to check whether it obeys the condition or not. So it obeys the condition. As you can see, it is a multi-source network. The one there is a voltage source and another one is current source. So here I have represented as Z1, Z2 and Z3. So there must be a components like resistors or capacitor or inductor in the place of this, or the combination of three also. So here we have to find the response in the case of Ix. So for that we have to apply the KVL for loop 1. So after applying KVL we will get Z1 I1 plus Z2 I1 minus I2. Why I have taken I1 minus I2 here? Because Z2 is common to both I1 and I2. So I have taken I1 minus I2 is equal to V. So after simplifying it, we will get Z1 plus Z2 I1 in minus I2 Z2 is equal to V. So here I1 is common from this equation. So I have taken out of I1. So after simplifying this equation, we will get I1 is equal to V plus I Z2 by Z1 plus Z2. So this is the, after applying the KVL of loop 1, we will get the equation like this. So then loop 2. So we cannot apply the KVL for loop 2. Why? Because here it is a current source. For the current source, we cannot apply KVL. So I am not applying KVL here. So here the I2 current is flowing. So here I2 is equal to I from loop 2. So here we have to find the response in the case of Ix. So I have taken I1 minus I2. Why I have taken I1 minus I2? Why I have not taken I2 minus I1 here? Why? Because I1 is flowing in the direction of Ix, but I2 is opposite to the direction of Ix. So I have taken I1 minus I2. We already know the value of I1. V plus I Z2 by Z1 plus Z2 minus I2 value is I, so I have taken minus I. So then after simplifying it, we will get Ix is equal to V minus Z1I by Z1 plus Z2. So name it as equation 2. So here we have to verify the equation by taking the two cases. Like we have to consider a voltage source and set current source 0 by open circuiting it. So here I have taken a network by I have open circuiting it the current source. As you can see here, it is a voltage source and say as it is the Z1, Z2 and Z3, and here I have to find the response in the case of I1. So after applying the KVL, I will get minus V plus I1Z1 plus I1Z2 is equal to 0. So after simplifying it, we will get I1 is equal to V divided by Z1 plus Z2. So I can also replace it as I dash because we are finding out the I dash responses. So I dash is equal to V by Z1 plus Z2. So then case 2, consider the current source and make voltage source as short circuiting. So we have to short circuit the voltage. So the current source is as it is here. So as you can observe here, so for the overall network, there was only the one network, only the one source is given here. So for that itself, we cannot apply the KVL. We can apply current division rule. As you can see, the current division rule says that main current into the connected resistor divided by the sum of the resistor which is connected. So here I am finding out the response in the case of I double dash. So I double dash is flowing in this direction. So I have to take it as Z1 and Z2. So Z1 and Z2 are the parallel there, we have to consider it as parallel, and I double dash is equal to Z1 by Z1 plus Z2 minus I. Why I have taken minus I? Because of the direction. So according to superposition theorem, Ix is equal to I dash plus I double dash. So this is the algebraic sum of responses we will get there. So V by Z1 plus Z2 minus Z1 I1 by Z1 plus Z2. So after simplifying it, we will get Ix is equal to V minus Z1I by Z1 plus Z2. So this is the final equation of Ix response from the algebraic sum of both I dash and I double dash. So this is the derivation of superposition theorem. So procedure for solving network by superposition theorem. So this theorem is applied to multi-source network. So apply KVL for loops in the given network. The voltage sources are made zero by short circuiting it, and current source is made zero by open circuiting it. Only independent source are made zero, dependent source cannot made zero. So independent sources we have represented like this. This is voltage source and it is current source. So independent sources, they depend on themselves and they consume its own energy. And, dependent sources, so it depends on other components. So it represented as a diamond shape. So let us move on to the problem. So here is the problem on superposition theorem. So the question is, using superposition theorem, find the current in 6 ohm resistor for the given network. As you can see, it obeys the condition. There is a voltage source and current source, and one it is dependent source. So first of all, we have to check whether it obeys the condition or not. So if this network obeys the condition, so next we have to analyze the circuit. We have to analyze the complex network and we have to convert it into simple network. So then we have to move further. The case 1, we have to consider a voltage source and make current source as 0 by open circuiting. So I have made it like this. So 18 voltage, and there is a resistor and which has represented at Vx and with the symbol of minus and plus, and there is a dependent source to Vx and the current is flowing. We have to find the response in the case of I dash, so I have represented as I dash. So there is a 6 ohm resistor. So after applying the KVL, we will get the equation like this. I1 plus 6I1 is equal to 2Vx plus 18. So in the place of Vx, we can apply minus 1 I1. Why I have applied minus 1 I1? Because I1 is flowing in this direction, but the sign of this 1 ohm resistor is minus. So I have taken minus 1 I1. So you can also simplify it as by Ohm's law, V is equal to I into R. We all know that V is equal to I into R. So I have taken as I1 minus 1. So in the place of Vx, we have to apply minus 1 I1. So after simplifying this equation, we will get 1 I1 plus 6 I1 is equal to, in the place of Vx, we already know the value of Vx, that is minus 1 I1. So minus 2 I1 plus 18. So after simplifying it, we will get in the place of in the case of response of I dash, we will get 2 amps. So in the case 2, we have to consider a current source and make the voltage source as 0 by short circuiting it. So in the case 1, we have taken the voltage source and we have make it as the current source as open circuiting it. So here we have to modify it. So here I have short circuited the voltage source and I have considered the current source here. So same, but in this given network, as you can see, the current source is common to both the loop 1 and loop 2. So when the current source is common to loop 1 and loop 2, we have to apply the condition, that is super mesh condition. So what is mean by super mesh? So in the super mesh condition, when the current source is common to both loop 1 and loop 2, we have to apply the super mesh condition. So we will get a constraint equation. So we have to apply the KVL for the loop 1. So we have to consider, I have represented as dotted line. So we have to take it as both the networks here when we apply the KVL. So 1I1 plus 6I2, because I2 direction is flowing through the 6 ohm resistor. So 6I2 is equal to 2Vx. So in the place of Vx, we have to represent it as minus 1I1, as the current is flowing like this. So we have to take it as minus I1. So from the Ohm's law, V is equal to I into R. So R in the place of R, I have taken as minus 1 and I is I1. So when we simplify it, we will get it as 1I1 plus 6I2 is equal to minus 2I1. So after simplifying it, we will get 3I1 plus 6I2 is equal to 0. So we will get a constraint equation. The I2 minus I1 is equal to 3. Why I have taken I2 minus I1, not I1 minus I2? Why? Because the current source direction is flowing like this, and even the I2 direction, I2 current is also flowing as same as the current source of 3 amps. So I have taken I2 here, but the I1 is flowing opposite to the direction of 3 amps. So I have taken minus I1 is equal to 3. So we have to take it as in the matrix form, that is 3, 6 and minus 1. Minus 1 and 1. So the unknown values are I2, I1 and I2. So 0 and 3. So when we simplify this matrix, we will get I1 is equal to minus 2 amps and I2 is equal to 1 amps. So I double dash is equal to 1 amps. Why? Because we are finding out the response in the case of I double dash. So the I2, we have to take it as I2 loop current. So for that itself, I double dash is equal to I2 1 amps. So by the superposition theorem, we will get I is equal to I dash plus I double dash. So it is the algebraic sum of responses. We have already find it out. I dash is equal to 2 and I double dash is, we already know that, 1. So we will get I is equal to 3 amps. So this is the problem of superposition theorem. I hope you understand this problem and theorem, and thank you for watching. Please do like, share and subscribe to my channel, and stay tuned for more interesting videos like this. Thank you.